Why Amsterdam's houses are so thin and lean forward. Look at a row of 17th-century canal houses in central Amsterdam. You see narrow, tall buildings packed side by side, tilting slightly out over the water. People usually assume this shape is a stylistic choice, a Dutch quirk built for charm. Property lines, tax bills, staircases, and a swamp wrote this silhouette. Every line of the building is the physical record of a strict constraint. The constraints start with the property line. In Golden Age Amsterdam, property tax on a house was calculated based on the width of its street frontage. Canal lots were laid out 5 to 7 meters wide. To keep tax bills down, owners often built even narrower than their plot allowed. Since building wide was expensive, owners found volume in the cheaper directions. They pushed the footprint backward into the lot and upward toward the sky. A typical canal house maintains that narrow frontage but stretches 20 to 30 meters deep and rises 15 meters tall, sharing heavy party walls with its neighbors. This deep vertical volume requires a very specific interior layout. To save floor space, builders used notoriously narrow, steep staircases that function more like ladders than stairs. The city's row of skinny façades is a tax made architectural, while the interior verticality is the direct result of maximizing a restricted footprint. But a 4-story house with a ladder for a staircase has a problem. You cannot carry a linen chest, a barrel of grain, or a piano up those stairs. Instead, you lift it from the outside. Look at the gable of any canal house, and you will see a heistbalk, a hoisting beam projecting from the roofline. Using a simple pulley, cargo is hauled from the street directly into the large windows of the upper stories. As a load is hoisted, it swings inward. On a vertical facade, it collides and shatters the windows. Builders solved this with a deliberate forward lean. Overhanging the upper stories ensures the cargo hangs safely in clear air. The famous forward tilt of Amsterdam is a piece of engineering designed to protect the house from its own delivery system. Underneath all of this engineering is the final geographic constraint. Central Amsterdam is a soft marsh of peat and clay. The ground itself cannot support a multi-story brick building. To prevent the houses from sinking, builders drove a forest of wooden piles down through the mud until they hit a firm layer of sand 12 meters below. The scale is massive. The Royal Palace on Dam Square sits on an estimated 13,659 piles. Wood kept underwater survives for centuries, but wood exposed to oxygen rots. Over 400 years, the city's managed water table has fluctuated. When the water level drops, the exposed pile tops decay at uneven rates. When foundations decay unevenly, the houses slump out of alignment. This creates a second, accidental tilt that compounds the intentional lean of the upper stories. A severely crooked house is a physical record of a centuries-long battle with the water table beneath it. Step back from the individual architectural quirks and look at the canal ring operating as a whole system. These combined constraints created one of the most land-efficient residential forms in existence. By sharing party walls and stacking functions vertically, shops on the ground floor, family in the middle, and storage on top, Amsterdam achieved extreme density on a fragile, narrow site. This design has proved remarkably durable. 4 centuries later, these buildings still function as active homes and businesses, using the same footprints and water transport that defined them in the 1600s. The silhouette of this city was never chosen for its charm. Every narrow facade, sheer staircase, and tilting roof was authored by a property line, a tax bill, a hoist, and a swamp. The entire skyline of central Amsterdam is a rulebook made visible in brick and wood. This is how the world builds. Every building is an answer. Tell us in the comments, what other beautiful urban feature do you suspect is the result of a rule no one talks about anymore?